How is everybody this morning? Is everyone as excited as me that this is the first morning of the conf and this talk will be over with soon? Good. My goals for today are to go over basics of writing a Python script and talk about how it can be useful to you in your work as a Mac admin. My name's Joe Chilcote. I currently work at Facebook as a client platform engineer. I've been in this racket for a long time. Did stints at Nordstrom and Adobe and Splunk before landing at Facebook. About 6 years ago, I decided that I needed to expand my skill set, and so I decided to try and learn Python. And I don't bring this up as any sort of humble brag or anything, but just to point out that even somebody as dumb as me can learn something new after 12 years of doing something. So I took a course, I think it was on Code Academy or Coursera, one of those online sites, with other members of this community, and we learned how to write an asteroid clone in Python, which is pretty cool, even though the GUI parts didn't really end up being super useful to me. But it taught me a lot about data structures and basic programming in Python. Having said all this, I am still an idiot, so don't take anything I say seriously. I wouldn't, for sure. This is going to be kind of an interactive session, by which I mean feel free to break out your Macs, try out some of the examples that are on the screen. I'm not really going to be doing any interactive demos, but the examples that are shown, you should be able to type into a Python interpreter in your terminal and get back some results. Also, if you get your Mac out and you just spend all of your time in Slack, I won't take that personally. Just don't say anything snide about me until I can get in there and defend myself. So, how many of you have written Python before? Show of hands. Okay, you might find this class to be pretty boring. Different question, how many have written a shell script? Much better. I'm going to ask this a different way. Raise your hand. All right, good. Leave your hand up. How many have written a shell script before? All right, that's more like it. The reason I bring this up is because if you've ever opened terminal and typed a command, then you've written a shell script. There's a bash history file inside your home folder that stores the commands that you've run. And in fact, you could probably manually run that bash history script, and it'll just loop through and rerun every command that you've run in the last few days. Probably a terrible idea. But if you are going to do it, you should do it with sudo, because then it'd be more fun. And with Python's interactive mode, you can similarly just type in a sequence of commands, and it will return data back to you similar to a shell. So you can try this out. If you open up your terminal right now, all you have to do is just type the word Python and hit return, and you'll see these 3 brackets, which indicate the Python interactive mode. And as an example, you can type in import anti-gravity. Does anybody know what this does? Mac? Mac knows. Yeah, it opens up an Easter egg XKCD webpage comic, which is a strip that is showcasing how awesome Python can be. And I can attest to this. Sometimes writing Python and trying to figure out what's causing an error feels like you've sampled everything in the medicine cabinet, for sure. One important thing to note is to get out of interactive mode, you type quit with the open and close parentheses. It's calling the quit method within Python. Otherwise, you can just mash your palm on the keyboard until Command Q happens or something. But sometimes it's difficult to remember how to get out of these things. So now raise your hand if you've written Python. By now, everybody has written Python. All right, we're done. It's lunchtime. So why Python? Shell scripts work just fine. Bash and now Z shell are included on macOS by default. And shell scripts are an easy way to run a sequence of commands, and sometimes that's all you need to do. But what if you need to do more than just run commands? What if you need to manipulate text or add a string to a configuration profile, save files to disk? What if you want to work with structured data, a plist file? What if you want to work with a binary plist file? What if you want to interact with the file system in ways that are more difficult to do in Bash? And also, Swift, of course, if you are working on a project that's going to be Mac only or iOS only, Swift is probably, frankly, a better option at this point. But if you're doing something that might need to be cross-platform, Python is still a great choice. And these are the areas where Python can really shine. Python was created by this fellow named Guido back in the late 80s. He was working for the National Research Institute of Mathematics and Computer Science, which is a totally made-up name, I think. But he's been the benevolent dictator for life of the Python project, and that lasted until last year when he gave up that title. And the lifespan of Python has been since the 1980s. There have been 3 major releases. It was named as an homage to Monty Python, not the snake. And in the spirit of Monty Python, the Python programming language is meant to be kind of a delightful experience and irreverent method of programming. And so keep that in mind as you work. It's supposed to be fun, right? Creating these scripts. And not be intimidating to use or read other people's scripts. He spent a few years working on the first major release of Python, and then the second release, which included a lot of useful things like extra memory management, Unicode support, came out in 2000, and that's kind of when Python really started to take off. And nowadays, I think it's very popular, especially amongst students. Because it is kind of seen as an easy language to kind of get a foothold in the idea of programming in general. The third major release was released about 10 years ago. This has been a bit of a controversial release because it's considered a backwards incompatible release. And so many individuals and companies have had difficulty porting their Python 2 code to Python 3, and I'll get into that a little bit later as well. Python is a high-level programming language, meaning that there are many modules and functions that you can use that will abstract away some of the lower-level programming bits on the system and also give you the ability to interact with the file system in ways that you couldn't do otherwise. It's an interpreted language, which means you don't have to compile the code to run, although you can. And in many cases, it may be useful to do that if you're including a bunch of third-party modules, or if you want your script to run on different platforms, and the path to Python is going to be different on Windows as it is on Mac or Linux. You can compile Python into a binary that you can distribute and run as well. It's referred to as a general purpose language. And it's due to how Python kind of includes a large set of modules that are built in that make it easy to get started with. But that's not to say that it includes everything that you might need. There's a wide variety and a vast ecosystem of third-party modules that you can use and import into your Python code. It just takes a little bit more effort to get those downloaded and imported into your scripts. Python's meant to be highly extensible, meaning that you can import only the modules that you want to work with. So you don't necessarily have to deal with the entire complexity of the language from the start. Part of that irreverent sensibility, Python code is often referred to as Pythonic. It's a bit of a recursive methodology there. But that's just another way of saying that it uses the Python idioms well, and that it shows fluency with the language. Python code conforming with Python's minimalist standards oftentimes has an emphasis on readability and simplicity, which is good for somebody like me. And by contrast, code that is difficult to read and is overly complex is also recursively referred to as unPythonic. And this quote is part of a set of guiding principles that were written back in the 90s by a fellow named Tim Peters. And in your interpreter, Python interpreter, if you type in port this, it'll return this list of guiding principles called the Zen of Python and display it on your screen. It looks like this, if you can read it. These are all, this was the 90s. These are all kind of milquetoast declarations, a bit anachronistic, but it does embody the spirit of Python pretty well. And it is good to check in with this list every once in a while just to keep yourself in check and make sure you're not trying to do too much and get overly complex with the stuff that you're doing. I have a few personal favorites. Listed here, explicit simplicity is very important, I think, because you want your code to be readable as well as easy to write and functional. Given how Python is built around white space and indentations, it appeals to somebody like me who's a liberal arts college dropout and not a computer scientist by training. And so for me, Python almost reads kind of in paragraph form. So reading Python can sometimes feel like reading prose, given the way that the indentations work and everything. And also the Python that you write should be easy for others to consume, and consuming your code also consists of reading it, and you want your code to be clear and simple as well. Before I continue, I want to make a quick note about Python 3. Like I mentioned, it's considered a backwards incompatible release. The most high-profile changes in Python 3 have to do with types and using maybe the print function. Simple things, but can be kind of laborious to go through and update your Python 2 code to be Python 3 compatible. There are projects out there. There's like a 2 to 3 module or script that you can run. There's linters that you can run that will give you advice on how you can make your code Python 3 compatible. But one of the biggest things is the strings Unicode support. In Python 2, a string is a string. In Python 3, they kind of combine the strings in Unicode together into a type, and they also introduce this other bytes type. And that's the sort of thing that can really cause trouble for you with your Python 2 code if you're trying to get it to run in 3. The print function is a little bit different. It's no longer just a statement that you run. It's a built-in function. So all of your print statements you're going to want to convert to this parentheses format before you can get those to run in Python 3 as well. And the raw input thing is for interactive scripts if you're asking for information from the user. Raw input in Python 2, I think, is deprecated in 3, and it's just input. So these are just things that you might want to think about, making sure that you're writing your code now to be Python 3 compatible. Also because Python 2 is out of support at the end of this year, I believe. Currently, Apple only ships Python 2.7 in macOS. And it's only included for support for legacy applications. I'm sure there are many Apple internal tools that use Python. Many packages will use Python in post-install scripts. I think even some binaries on macOS, like the Xadder binary, are Python as well. And they've continued to include 2.7 for this compatibility with these tools. However, they have publicly stated with the Catalina betas that they're recommending now that you bundle your own copy of Python to include with your applications. And this is actually good news because you're not dependent on what's on the system. You can include third-party modules with what you're bundling. You can kind of be in more control with what you're doing, but it does add some overhead to what you're going to do, so you want to plan ahead for that. Luckily, our own Greg Nagel has written, of course, a Python script that will bundle up and build a Python framework for you. And it works to build a Python 2 or a Python 3 framework, and he does the hard work of including the PyObjective-C framework, which is, I'll get into a little bit later, but it's kind of glue code between Python and macOS, the core frameworks within Cocoa. So you can do things like create GUIs for your apps. And he has a script that you can just run. It'll create this Python.framework that you can then bundle up with your app, or you can install it in a known location on your client devices, and your scripts can call that version of Python directly from there. And I just want to point out, has anybody ever seen these two men in the same room? I'm starting to think that Greg has a secret identity as the benevolent dictator for life. Okay, getting into the internals of Python. Like I said, it's an interpreted language. There are no requirements for type declaration in Python. You can just declare, or you can assign a value to a variable, and it'll infer the type of that variable based on its attributes. So a string is a string, and a number is a number, that sort of thing. And again, this makes Python very easy to get started with, easy to write, and fairly easy to debug, because you will very quickly find attribute errors where the Python code is expecting a number where you're passing it string, that sort of thing. You can declare variables statically typed variables in Python. And I think that's more of a thing in 3 as well, but it's not required in the language. So a string is just a built-in class in Python. It's an object type, and it accepts values that are, enclosed in parentheses, or I'm sorry, in quotes, single quotes or double quotes. You can use backslashes similar to in Bash to comment out a character like a new line. You can enclose a string that includes a quote inside a quoted string. You just want to swap the doubles and singles. So if you have the word don't in your string, you'd want to enclose that in double quotes. Some linters out there, like the black linter, will yell at you and try to force you to use double quotes everywhere. But then a lot of the Python documentation uses single quotes. It's kind of a personal choice. I got used to using single quotes, so I kind of stuck with that, but now I get yelled at a lot. Strings are immutable, so what that means is you can take a string, a variable that's a string, and you can do stuff with it, but you can't change it. So if you want to, in this example, you want to take a string that has a single word, and you want to multiply that word 3 times and return the same string that's going to be triplet, you would want to assign that to a new variable, and then you can manipulate that variable from then on. The string class has a bunch of built-in methods that can be called to manipulate the string object itself. The lower and upper functions there are pretty self-explanatory. You can take a string and you can capitalize all the letters in it or make them all lowercase. And this is useful a lot of times when you're doing a comparison. Say you're looking for, you want to find a word inside a sentence. I mean, you may not know whether that word has any capital letters in it. You could standardize that sentence all in lowercase and then search for that string in lowercase, and then it'll return the true or false value from that. The starts with function is, again, self-explanatory. It just gives you a true or false about whether your string starts with those characters. In this case, it's false because we're looking for spam. And replace is similar in that you can take one section of the string, replace it with another. It's kind of an abstraction away from a regular expression here. So if you want to replace a value within your variable, you can do that with this function. And again, strings are immutable, so you're not actually changing that variable in this case. If you wanted to actually change that value and then use that later, you would want to create a new variable based on that you can work with. The strip function is basically just kind of a way to chop off the beginning and end. So a lot of times you're pulling in data from an external source, and it might have a bunch of new lines. You can use strip to chop off that new line at the beginning and end of the string. Similar to, I think, chomp in other languages like Perl, I believe. Split is an interesting one. It's very useful. You can turn a string into a list of objects. By default, with no arguments, it just uses white space as a delimiter. So if you take a sentence and you run split against it, you will get back a list of every word in that sentence with all of the spaces removed. And in an example coming up, you'll also use the strip function ahead of this to make sure that you don't have any empty strings at the beginning or end of your resulting list. So here's an example where we have some MontyPython lyrics assigned to a string, including some new lines, and we're using the split function or the strip function followed by split based on the new line character. So you're basically just saying, give me every line in the stanza and turn that into an item or an object in my list. In this way, with the strip, you don't end up with any empty strings at the beginning or end of your list. Similar to strip, slices can be used to break up strings into chunks based on the index value. Every string object in Python has an index. That's basically the characters in the string, starting with 0. And you can define the begin or the start and end index of the portion of the string that you want to strip out or slice out. So in this example, we have a string called flesh wound, and we're telling it to return everything from the beginning up into the 5th index of the string. So we just get back the first 5 characters. Technically, you're getting the 0 through 4th character there because you're going up into 5. And that's something to remember because that you can get bitten by that. The second example there is kind of the converse. We're saying go to the end and walk back 5 spaces and give me the remainder there. And the third one is doing the same thing, just telling it from index 5, go to the end. And you can also slice out the middle section as well by providing a beginning and end index that you want to pull out. And this can be useful. I've seen this used when evaluating like an IP address or something that you know is going to be a specific number of characters. You could use this to ensure that you're only returning the data that you want to return. String interpolation is a way to kind of insert dynamic data into a string. So there's an old style and new style. The new style is Python 3 compatible, so get used to using that. My brain doesn't do well with learning new things, and so I still use the old style a lot, way too much. But you can either put the %s in there, which is just an indicator, and you can have as many as you want, and then you pass it a list of variables at the end, and it will just go back and replace those in order. The new style is using the double squiggly brackets with the dot format nomenclature there. And again, you can have multiple double squigglies in your string and then pass it multiple variables, and it'll go in and replace those in order. An integer is similar to string. It's another built-in class. And like strings, it comes with features and methods available to it. You can perform basic math on integers in Python, and you'll get back what you expect, usually. In this case, we're adding 12 to a variable that's been assigned the value of 12, so we get back 24. You can also evaluate it with greater than or less than signs to give you back a Boolean, true or false, whether something is larger than the integer that you're passing. Again, typical math operations work. You can get the sum, difference. The remainder is an interesting one. So if you did 12% 5, you would get back 2 because that's the remainder of that quotient. And the double asterisk there is exponential. So if you had 2 asterisk 4, you would get 2 to the power of 4, which is what, 16, I think? My math is terrible. The one area where you can run into trouble in Python 2 is that integers are absolute. And so if you're doing a, okay. Sure. Okay, is that any better? Excellent. In Python 2, integers are absolute, and so if you do a division, for instance, 12 divided by 5 here, you would get 2 instead of 2.4 if you pass an integer. It's kind of a weird thing. So you can declare a float in Python by giving it the .0 there. It just kind of tells it that you want it to be evaluated as a real number. And if you do that same evaluation there with the division, you'll get the proper 2.4. I believe Python 3 normalizes this with the integers, but that's worth checking out as well. Lists are another basic type in Python. They contain a sequence of objects which can be any other object type. So you can have a list of strings or integers, dictionaries, objects, pretty much anything that Python can consider an object, you can throw into a list. Lists are written within square brackets and are multiple objects collected into a single unit, which means you can add or remove items from a list. So the append function there would add an extra cheese to this list of cheeses. Extend is a way of taking one list and just glomming it on to the current one, adding them together. Remove, again, you can call something directly by its name and it'll remove it from that list. I believe you can do that with the index of the item in the list as well. Lists work similarly to strings in that they do have an index starting with 0 as well. You can call the items by the index number, and which means the first item in the list is going to be 0, but you can call the last item in the list by giving it that -1. So you may not know how long your list is, but you know that you want the last thing in it. You can use that to pull that. And the pop function is just a way of stripping off that last item in the list as well. So if you have a list of items and you know the last one, say, is irrelevant, you can then pop that off and return a list that would just be everything up until that point. So in this example, Gouda was the last item in the list, and we popped it, and now it no longer is. You can sort lists in place with the sort method, which will reorder the items alphabetically there. The object will be represented by this new ordering. You can similarly use a reverse to reorder it in a reverse alphabetical order. And I believe it's alphanumeric too, so if you have numbers in there, it'll use those as well. If you don't want to change the ordering of the list that you're working on, you can use the sorted function, which will give you a new list in that new ordering that you want. So many times you may not want to affect the list that you're working on, but you want it to be in a specific order. So you would just declare a new list as this one, but in a sorted function as well. There are other attributes that you can pass to this. The reverse equals true in the sorted will, again, just put it in the reverse order, alphanumeric. The key length is interesting because it'll sort it by the length of the strings inside that list. So it'll go from the shortest cheese to the longest here. Another optional argument not shown in the example is this string lower, which will ensure that, say, a lowercase z won't come before an uppercase a, because normally it would put them lower than upper than numbers, or maybe in a different order. But it's ways of getting your data into a format that you might expect. Tuples are kind of like lists, but they're immutable. So if a tuple has 3 items, it will always have 3. You can't add or remove anything from that. In this example, we're trying to add a TV show to a list of Monty Python related TV shows, and it is complaining with an attribute error telling us that the tuple object has no attribute append. I've heard it pronounced as tuple as well. I actually don't know how you pronounce this, but I'm going to go with tuple. Often it makes sense to trap for these sorts of errors, because otherwise your program will crash out, and you may not want that. So you might want to expect that occasionally you're going to get an attribute error like this if you're working with data in a format that the program may not expect. Sets are defined as an unordered collection of unique elements. Basically, I think of it as a way to deduplicate a list. So in this example, we have 2 Terrys in our list, Terry Jones and Terry Gilliam. If we create a new object and tell it to be a set of that list, and then we print that object down below, we print that set, it will print back with only 1 Terry. And I'm going to assume that they removed Terry Gilliam, because I don't think he really did that much anyway to begin with. Dictionaries are another basic type in Python, similar to lists, but a dictionary is a key value pair. Other programming languages would call it a hash. It's a collection of keys, which can be any immutable type, like a string or a number or a tuple. And then the values that are associated with that key can be of any type that Python recognizes. So it can be other lists, it could be other dictionaries, it could be objects, anything in there that you want. Python dictionary is a key value hash, like I said, and written as a series inside braces like this. So whereas lists are in square brackets, tuples are in parentheses, dictionaries are indicated by this brace format. So similar to how you can call an item from a list by either its index or its name, you can call a key from a dictionary based on the name of one of the keys, and it will return you the value that's associated with that key. They can be called directly from the dictionary. In this case, we're telling it to return index 0 of the list that's associated with the key philosophers. So we're getting that first name in that list. However, like I mentioned earlier, with the attribute error, you're going to run into problems here where you might get a key error if the dictionary does not have that key that you're asking for. So oftentimes it's good to trap for this sort of thing, like with a try and except block. But also you can use the get function on the dictionary itself and look for a key. And if that key exists, it'll just return you what is the value that you're asking for. If that key does not exist, you can pass it a default value that you want it to be. So this can be useful if you don't know what's in a dictionary, but you want to pull some value out of it if it is there. You can use this method and then default to none or an empty string or something, and then later on in your script you can say, if this thing exists, do something. If not, move along. It's a way to avoid getting these key error exceptions in your code. You can also return all of the keys or all of the values from within the dictionary. This is useful if you are evaluating and you want to look and see what is available to you. It returns as a list, and because the value associated with the key in this list is a list itself, you can see down below there it returns as a list within a list. So you want to be cognizant of that, because if you're looking at the index, you might have to have like a nested index of like a bracket 0, bracket, and then look inside the list that was kind of encoded within that list. That gets pretty complex when you start looking at things like system profiler output in XML, and you pull that into a dictionary. It has tons of nested dictionaries and lists, so you end up with a long variable string where you're just like stringing a bunch of bracket zeros, bracket 1, bracket 0, bracket 1, and then you look for the key that you're interested in. The items function on dictionary is a way to return a tuple of the keys and values within your dictionary. So that gives you the opportunity to iterate on dictionaries and perform actions on every item inside there. It returns that as a tuple, which again is immutable, so you can say for every key and value in this dictionary, just print out the key and then print out the value. And here we have 2 keys, philosophers and drinks, and then the values are represented by lists. The attributes of lists also make it easy to iterate over, similar to dictionaries. If you have a list of movies, you can iterate over that with the for and in loop. So you can say for movie and movies, print movie, and it'll just loop through, grab every item from that list, and print it out for you. Notice too, this is where the white space is starting to come into play. Python expects that these sorts of declarations where you have the for something in something colon, or if something colon, that the next line will be indented. That's how it knows that you're doing a loop in that manner. Other programming languages will have a deterministic way of doing that, like Ruby uses begin and end, so you would have to write the word end at the end of all these things. Bash, you have the if then statement bash, you have to end it with that fi at the end, which is always the thing that I forget. Going back to write bash after playing with Python is, man, you have to go read the documentation again on bash. It's terrible. But again, this, in my opinion, increases the readability and simplicity of Python. Kind of makes you feel like you're reading a logic flow rather than just a bunch of functions being thrown around. A list comprehension is a more complex way of doing a for loop, but it kind of, in my opinion, increases the readability in a way, because it's a very succinct way of looping through a list and then creating a new list based on some attributes that you're looking for. So here we have a list of numbers, and we want to create a new list of the square roots of those numbers. So we can just say, with the math function that we've imported, we can say, just return to me the square root of each number in this list, and then give that back out as a new list. And so we end up with a list containing the square roots of those numbers in there. Booleans. Similar to an if statement in Bash, which you can do things like if this path exists, or if this path is a file, or if this variable is not empty, that sort of thing. You're asking a true or false statement. Python has a similar idea of Booleans as well, representing a true or false state. However, Python can get kind of weird about Booleans. While true and false can usually be pretty easy to figure out, in Python there are states like none or empty strings, and these are sorts of ways that you can also determine false in Python. So you just want to be careful about when you are evaluating a true or false statement to think about what you're passing to that, because it may not return what you expect. It's pretty easy and straightforward if you're just evaluating a few things. If you're saying if this one statement is true and this other statement is true, you would expect that adding those together would be true. If you're evaluating a true statement and a false statement, you would expect that to be false because one of them is false, and that's going to indicate the whole thing. What do you think this would return? Who thinks this will be true? And who thinks false? Who is not paying attention? All right, there's you. Yeah, it's false. And this trips me up every single time, because I think, in my brain, I think if this thing is false, or if this thing is not true, and this thing is not true, then I want to do something. That makes sense to me. But it's going to return as false, and it's going to skip the thing that you want to do. So it's important to kind of think about the Boolean operations that you're doing in Python and make sure that they're returning the combined value that you think they're going to return. Modules within Python, there's a bunch of built-in modules that are super useful. And I want to quickly go over how they're called and how you can import your own as well. Python, like I said, is a functional language. What that normally means is that Python is declarative and will return values based on the arguments that you provide. So in this example, we have a definition or a function called AddEmUp. All we want to do is just add two numbers and return that value. And the reason we would do it in this way is because this is declarative, right? You give it two numbers, and it's going to give you the product of those two numbers. You can do this 100 times with 100 different pairs of numbers, and you can be reasonably assured that the data that you're going to receive is what you would expect. Functions are good too if you're going to be calling something multiple times in the script. You don't want to have to write that code over and over and over, so you can just write it once and then call it several times in your script. And again, you can pass any number to this function and it will return the product of the two numbers, but if you want to be super careful, you would want to put some error checking in here to make sure you're not passing strings or other object types that would then throw an error when you try to add those things together. Some common built-in methods that make life working with Macs easier are built into Python itself. The OS module it includes functions and methods for interacting with the file system. So looking at file paths and that sort of thing. Subprocess is a way to create child processes. Normally, you would do this to call some binary or run some shell script or run some bash command from within Python and then return the output back to you that you can then work with. And the JSON and plist_lib methods are ways of interacting with structured data. So you have a plist on disk or a JSON file on disk. You can import those into your script and convert them into a database object or a dictionary object. And then you can interact with the data in that way. It doesn't have to be pulled in from disk. You can also pass in a plist via a string as well. So it becomes useful when you're evaluating plists on disk and then you want to write it back out with different values for the keys in that plist. You can do that with Python very easily. The OS module, again, has lots of functions available to it. One useful one is the OS path exists. This is just a way of evaluating whether a path is true or not. In this case, it actually returns as false because I passed it a relative path, and the OS module doesn't really know what that is by default. And so even though I can prove that that file does exist in my home library folder, this module will return false and think that it is not true. Luckily, there is another module within the OS path. There's another function within the OS path module called expand user, which does kind of what it sounds like. It just says, oh, we're going to take this path and put it into the current user's home folder and evaluate it that way. And this, as you expect, would return as true. This is useful in a lot of ways. If you're, in this case, if you want to look at the Nomad preferences and pull data out of it, you might want to check first to make sure that the file exists. Otherwise, you would be attempting to load a file that isn't there, and you might get an error. And now that we've determined that the path is real, we can do other things with it, with other functions within the OS path module. Base name and dir name are useful in that they return the enclosing directory or the file name of the path that you're looking at. And if you wanted to give it the path of this expand user, it would then print out the full real path, absolute path of that file, not the relative path. So again, passing it that expand user kind of tells it to be smart about where you're looking inside your home folder. And then if you wanted to, you had a folder and you were iterating through that folder looking for a specific file, you find that file and you want to return the path of that file, you could then assign variables to those two items and pass that to an OS path join, which just takes two strings, pushes them together, creates a new path out of that. It's a quick way of, say you have a folder on disk which contains scripts that you're pushing out to your clients, and that folder has a very specific path, library CPE or something. You could store that as a variable in your script, and then when you get to the part where you want to interact with the file, you could just say OS path join, give me the path of where all my scripts are, give me the name of my script, and it'll return to you the path of that script, the absolute path. And we get the same path that we set up before and that we expect to be there now. And we can then work with that path further down in our script. You can combine the ability to determine that relative directory with the OS lister function, which is just a way of iterating through all the files within a directory and returning to you the names of those files. And this is useful if you're, say you have a directory of company wallpapers that you distribute out to your clients, and you want to delete some of the older ones. You can say, iterate through this directory, if you find a file with a specific name, delete it, and then it won't affect any of the other files in that path. Subprocess, again, is a way to create a child process. Many times it's used to shell out to bash and then return data back from that command. And again, reasons why you would want to play with Python rather than shell is if you're doing more than just running a bunch of commands, if you're working with structured data, bringing in data from other files. But sometimes you do just want to run a command. And it is useful to take advantage of what is on the system already instead of having to try to recreate that within Python. So with the check output function on subprocess here, we're just saying return to me the standard out from this process. In this case, it's giving me the system information from that uname command. There is danger in this as well. If that command that you're calling crashes, then your entire Python process will crash. So it's useful sometimes to throw this into a try except block where it'll attempt to run that script, and if it fails, you can have it do something else, like maybe print a nice error to the log, or just move along and not do anything, or maybe you do want it to quit, and you can just have it quit cleanly and give you an alert about what went wrong, that sort of thing. You can go deeper with the subprocess module by creating an object out of a process. It's a little bit more complex, but you can pass a command, and you want to pass it as a list here. And subprocess will add that list together into a string for you. And this is a way that you can gather the standard out or the standard error of that process that you're running. And we can call that function with the communicate, or we can call that method with a communicate function, which creates an object and returns output and error. So you can have a conditional that looks for an error of a particular subprocess, and you may bail at that point or do something else. Or you're getting the output of that process, and maybe the output is an XML data. And then you can work with that as structured data later on in your script. The built-in JSON method is a way to work with structured data. You can pull it in from an external source, like a file on disk, or you can pass it in as a string. In this example, we're pulling in a JSON file from disk, and we're opening it and running the JSON load function, which just brings in that structured data and creates a dictionary, a Python dictionary out of it. And then you can manipulate that dictionary later on in your file. Once we determine that a file exists, we can load and pass that file to the loads function of the JSON method, and we end up with that standard Python dictionary as a result. And if you print that dictionary, you just get everything in there, and again, you can just call it by its key name and return that value, that sort of thing. Once we consume the data in a standard format, we can manipulate it and then use the same JSON module to save the data back to disk or create a new file on disk. So say you're bringing in some data, you're manipulating it, you're changing one thing from true to false, you can write that back to that JSON file. So later on when you run that command or run that script, it'll pull in the new data. And you can ensure that your JSON file is properly formatted by telling it explicitly the indentation and separators that you want to use. JSON can be pretty weird about those comments, I think. plist_lib is similar to JSON in that you can interact with plist data on disk or via string output. In this example, we're querying the info plist of Firefox to determine the version that's installed. Because the data returned is in the structured format, it's easy to just extract the data that we want. So in this example, all we care about is that short version string, so we just call it directly from within that dictionary. Otherwise, you may get just a whole bunch of data that you might not care about or want to deal with on disk. Two other interesting modules are the argparse and logging. Now I'm going to quickly go over those, starting to run out of time here. Argparse is a way to make interactive command line interfaces easier to create. You can import argparse like you do any other built-in or third-party module. with the import command, and you can define the arguments that you want to track. So in this case, we're tracking a list in version JSON and quiet. So if the user passes that -- list, it just prints out a list of options, whatever you want to return to them. Version, you can have a specific variable in your script that keeps track of a versioning that you're using. JSON, you may want to ensure that the output is formatted in a JSON format. Or quiet, say it's not meant to be an interactive script, you want to run it headless or something, you can tell it to run without any output at all. And finally, logging. Finally, you add the additional argument at the bottom there, and I think I left out this part. There it is, args equals parser. So this way, it collects all of those arguments as a list, and then later on in your script, you can say, if an argument equals quiet, do this one thing. If not, do another thing. Moving on to logging. This module makes event logging pretty flexible with your Python scripts. You can save log out to a specific file. You can have it go stream out directly to the terminal. When creating a logger, you can add handler definitions for like the format, the date time format, that sort of thing. The logging level is kind of interesting. A debug log, you might want more logging to happen. If anybody uses managed software update, if you pass that -VVV, you'll just get a whole bunch of output. It's probably doing something like this, where it's saying if VVV return debug log. And then you just create an object there and add in the handler information that you're creating. And you can tell it to use a stream handler so that it'll send that data to standard out in the terminal, as well as save it off to a file that you define as well. And then in our script, we can call this logging function directly and send a string which will be sent to our log file. In this case, we're just passing some hardware data about the machine that we're on using the string interpolation that we talked about earlier. I chose debug log in that setting, or in that example, because it's the most verbose of the logging. It kind of goes in this order, with debug being the most verbose and critical being the most restricted. So you can use this methodology to only return values or only return the logging level that the user wants. So for instance, you could tell them to pass an argument called log level with the log level that they want, and they'll get back the verbosity of logs that they expect. So by default, you could say only return critical logs, but if they pass log level debug, then it'll start passing a whole bunch of stuff to them. And again, you can combine these two things, argparse and logging, to allow the user who's interacting with your script to be able to define the level of logging that they want to use. So if you have debug in the log, it would show any log level that you're throwing in your script. But if they do info, which is usually the most common, it'll leave out those logging debug lines that you're throwing. And so they won't get quite as much data. And again, as you move down that list of verbosity, it becomes smaller and smaller. And if you imagine if you just called the critical message log level, you would only get those critical messages. All right, quick example. This is one of the very first scripts, Python scripts I ever wrote. I am a big fan of a band called Guided by Voices from Dayton, Ohio, if anybody knows them. They're known for a few things. One is that they're extremely prolific. They've written hundreds, maybe thousands of songs. And their song titles are kind of absurdist and random and long. Some examples are like Goldheart Mountaintop Queen Directory, completely meaningless, have nothing to do with the song, which is one of the reasons I like them. But I thought it would be fun to write a little script that generates Guided by Voices song title. So using the random module from within Python, I'm importing a choice and randint function. Choice is just a way of passing a list, and it'll just choose randomly from that list. In randint, you can pass a range of numbers, and it'll choose a random number from between those. So what I did was there's this file on disk that's on everybody's Mac, which is kind of ridiculous. It's a file that just contains the most bizarre words that you can think of. So I'm pulling that in, running the readlines function, which splits it based on the new line character by default. So you end up with a list of all your words from that file. Using the randint function, I'm telling it to choose a random number between 4 and 17, and I pass that number as well as that list of words to this getSongTitle function, which looks inside that list of words and pulls out randomly the number of words that you're asking for, and then returns that to you. I do a little bit of checking here to make sure it doesn't get ridiculously long, so I make sure that the whole string is not going to be longer than 114 characters. And then it returns the song title to you as a string. The string.join function there is just telling it to take that empty string, or take a space, and add everything within that list to that space. So you end up with basically a sentence. So when you run it several times, you end up with something like this. Like I said, the words in that file are kind of, I don't think they're actual words. And I have no idea who maintains this thing, but I kind of feel like if I could get a job at Apple maintaining this file, I think I would be really good at it. I think mail-clad disfeaturement is my favorite there. So real quick, PyObjective-C is, again, glue code that you can use to interact with macOS core foundation frameworks, Cocoa. It's particularly useful for creating GUI apps, but it can be used in command line scripts as well. Two popular open source projects that have used PyObjective-C are AutoDMG, AutoDamage, and Managed Software Update. However, with Apple inventing Swift and with the new Swift UI announcements at WWDC, I imagine that using PyObjective-C for GUI apps is probably not going to be as useful or popular going forward, because Swift seems to be pretty easy for doing that sort of thing. And in fact, Greg has completely rewritten MSC in Swift in the later versions, I think 3.6 and above, if I remember correctly. So while the core Monkey Tools product is still Python using PyObjective-C, everything runs in Python. The GUI that you see with Managed Software Center is in Swift. And he did a talk at Mac DevOps YVR this year about the experience of doing this and how creating it in Swift kind of reduced the complexity of the app, makes the launch time shorter, that sort of thing. If you ever Google for PyObjective-C examples, you will always find yourself on one of Mike Lynn's gists in GitHub. He's a bit of a maniac. I don't know how he figures this stuff out. But he has lots of examples on there that you can just take and play with and stick into your own scripts. But he gets pretty deep into the core of PyObjective-C and doing things like C types and pointers and more programming things that normal people like me don't understand. But in this example, he is loading an NS bundle into the Objective-C class and then extracting out information like the serial number and UUID of the machine. So then you could call this function within your script and say, give me the IO platform UUID or serial number, and it will return that to you. There are other ways of getting this information through the IO reg bash command or maybe system profiler. But because Mike is Mike, he wanted to figure out how to do that with PyObjective-C. And like I said, there's lots of super useful examples on his GitHub. They're under Pudquick. But you don't have to do complex stuff like that. There are a couple of PyObjective-C frameworks that are super useful. One is Core Foundation, and one is System Configuration. And you can call those directly from within your Python script in macOS because it's all built in. Core Foundation contains functions that can be used to interact with the CFprefs database, kind of similar to running defaults in Bash. The sorts of things that you would use defaults for are like checking the value of a preference, that sort of thing. You can do that directly with the Core Foundation APIs in macOS directly with Python by using this. And one area where this is more useful than using defaults in Bash is if you have a configuration profile setting a value in a preference domain, sometimes that value is not returned by defaults. When you check against the APIs, you may get more reliable information back about what's being managed in the configuration profile. In this example, we're telling it to import these two functions from the Core Foundation framework. We're giving it a domain. We're telling it what key we want to check. And then we're asking it to print out that key value, whether it's true or false, whether it exists. And then secondly, we're checking to see if that key is forced. Like forced with a configuration profile. So when they go to the system preferences and hit software update, those values would be grayed out, that sort of thing. If we run this code, we would get the values that we would expect, depending on whether we're managing those keys in that preference domain or not. And again, if the user goes into system preferences and checks this, they'll see that those options are grayed out as you would expect and as you're managing it. Taking a step back, you can also just print out all of the keys in a preference domain. And again, for this software update example, because Apple still has not added support for every key in the software update domain for configuration profiles, this is a useful way, in lieu of documentation from Apple, this is a useful way to see what sorts of keys are available in that domain. So using the CF preferences copy key list function from the Core Foundation, you can list out all of the keys that are available. And some of these you may not, I've never heard of. Some of them I have no idea what they do, but then you could go in there and play with them, set them to true, see what happens. Maybe there's some undocumented setting that you can put in here that would be useful for you. System configuration is another useful API that you can call to return information about the device, among other things. Many of these settings and values can be obtained through the command line scutil. If you've ever played with that, you can get like the hardware type and that sort of thing. Here we're using the sc dynamic store create and store copy value functions from this framework to return, we want to return the host name of the machine. And hostname can be weird sometimes if you're in an environment that has a lot of VPN users or you have dynamic DNS. Checking hostname based on NS lookup or something can sometimes be unfruitful. You might get information back like your Mac is calling itself an iPhone or something. This is a way of asking the Mac itself what its hostname is. So you could use this in a Jamf extension attribute, for instance, and it would return that host name, and then when you're looking through your JSS, you can say, okay, I know what this host name is. It's assigned to this user and whatnot. Because it returns as structured data, you can then just use standard Python dictionary nomenclature to pull out that hostname key from the sysinfo object dictionary that you've created there. When we run the script, we get the data that we expect. And in this case, I'm also wrapping it in the XML format that JSS extension attributes would expect. This example was a little bit more complex than the earlier ones, and you might notice this name equals main thing at the bottom. It's a little weird, but Python has these kind of global variables in that are stored in memory when you run a script. And one of them is this name variable. It's a special variable within Python that it can use to do certain things. And you can check if it's called _main. That usually indicates that you're interactively running a script. So you can have output be different if you're interactively running a script as opposed to whether your module is being imported into another script somewhere. So usually you'll see that if name equals main in most open source Python scripts that are intended to be run interactively. All right, so real quick, bringing it all together. At a previous job, I was using Jamf to manage Macs, and I wanted to have kind of a centralized way of returning data, like hostname in that previous example. So I created a Python module that I have up on my GitHub called Unearth, with the idea that I'm excavating data about the Macs. I modeled it after the Monkey Facts project, kind of this spiritually modeled after Puppet Factor as well. So the idea is that you could get data returned by interactively running a script, or you can throw it into your extended attributes, extension attributes in JSS, and have that data returned back to JSS for your reporting. Real quick, this is an example of checking the battery status percentage of the Mac. And the idea here is I wanted to not do expensive operations on the machines if the battery was below 20% or something, like installing Office. And this just shells out using subprocess to the PM set, pulls in that data, and then does a regular expression against that string that it pulls back, and extracts specifically the battery percentage out of that string. Another short example is using system configuration, SC dynamic store copy console user, which you can use to determine the user who's logged into the system. There are lots of examples out there about using, checking stat against Etsy console or some other thing. This is a way of using Apple's built-in APIs to determine the logged-in user. And in here, I'm throwing it against a discal command to determine whether that user is a member of the admin group. And it just returns a true or false of whether they are an admin or not. So if you run the module directly or run the script directly, it'll just return the values as a key value pair. If you run it with JSS, you'll get it returned with the expected XML format of an extension attribute. So you could just copy and paste the stuff directly into an EA, and it would return the value that you want. Or you could pass multiple categories as well and get the data back that you want. I found this pretty useful. I don't really use it much anymore in my current job, but I would encourage you to go in there and steal whatever you can, or add more, or update any of the ones that have broke since I was using it. I know some other people in the community are using these and find them sometimes useful as well. You can also, in your own Python script, you can import this method directly and then interact with it there. So you don't necessarily have to run the commands that are provided up in GitHub. In this example, we're skipping an Office install if we determine that the battery percentage is below 20%. All right, I made it with 2 minutes left. Tonight. Is today Wednesday? Yes. Tonight, Greg is doing a Python 3 convertathon in the Hacker Cabin, which I think is right over there. Jeremy is doing a session tomorrow at 1:30, which is probably going to be a little bit more in-depth than this one, which I encourage you to go to. There's a bunch of links here. This will be available to you later. That first link is a survey that Jeremy asked me to put up here. So if you want to go in there and take that survey, that might help him with his talk tomorrow. Question? What level of Python knowledge do you need to take part in the convertathon was the question. I imagine that it'll be beginner friendly. Show up and at the worst, you'll learn something, I'm sure. Yeah, especially the differences between 2 and 3 can be weird and complex. All right, thank you.